In this chapter, we're going to be reviewing and introducing concepts in geometry and transformations. In this lesson, we're going to look specifically at dilations.
Okay, everybody, and the last transformation we're going to look at here is a dilation. And a dilation is when we change the size of an object. Okay, so we're going to be given a scale factor, and we're going to use that and apply that to the shape to change its size here. But this is what we're going to call here a linear scale factor. So that means that the lengths of the sides is what's going to change here. Now, not the shape. The shape is going to stay the same. We're going to end up with a similar shape to the original. All the angles are going to stay the same. The overall shape will be the same, but the lengths are going to be different. Now, that's also going to affect the area of the problem, or the area of the shape when we change it from one to another here. But that's not what we're really concerned about. What we're concerned about is the lengths of the sides here. So if the scale factor is bigger than 1, okay, then the resulting image is going to be larger. Okay, this is going to lead to a larger image here. But if the scale factor is less than 1, it's between 0 and 1. Okay, because we're not going to talk about negative. That really doesn't make any sense here. It's going to be smaller than the original. Okay. So the sides will have the same ratio to each other. So, you know, the height to the height, that ratio will be the same as the base to the base sort of thing. But the areas are going to be exaggerated by a different scale factor. And I don't want you thrown off by that, because sometimes that is confusing. Because you look at something and you say, well, wait a minute, I made the lengths twice as big, but the area looks way bigger than that. And yeah, that's exactly what you're going to see there. Just focus on the side lengths and you should be fine. Okay, everybody, so look at this question right here. It says, draw a dilation of the following image with a scale factor of 3. Okay, scale factor of 3, meaning all of the line segments that we're going to use here, we're going to make them 3 times bigger. So I'm going to start, okay, let's say I'm going to start with this point right here. And I'm going to drop that, I don't know, I'm going to drop that, let's say, right here. I don't know, I'm just kind of guessing here. So 2 down. I want that to be 3 times as big. 1, 2, 3. Oh, that's actually not a good position for it, because I need this to be 3 down. I need to be able to expand this one out as well here. So let's maybe go up a little bit. What if I start here? So this is 2. So that distance is going to become 6. 1, 2, 3, 4, 5, 6. And then this distance from here to the bottom is 1. So it's going to be 3. Okay, that works here. So I'm going to start here. So this little bit right here at 2, if I multiply by 3, is going to become 6. So 1, 2, 3, 4, 5, 6. Now, how do I get to this point right here? Well, in this shape, I went down 1 over 3. But I'm multiplying these things by 3. So instead of going down 1, I'm going to go down 3. 1, 2, 3, and over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my new point. So it's these linear distances that are getting multiplied by 3. Now that is ultimately going to end up multiplying that length by 3, but I don't need to worry about that. To go from this point up to this point, I went up 1 over 2. So that's going to be up 3, 1, 2, 3, over 6. 1, 2, 3, 4, 5, 6 to this point right here. Then I went up 2. So it's going to be going up 6. 1, 2, 3, 4, 5, 6. And then to get to this point here in my shape, I came left 1, up 2. So it's going to be left 3, 1, 2, 3, then up 6. 1, 2, 3, 4, 5, 6 to right there. Connect. I could have done that better. Connect those 2 dots there. And then this one is 2 to the left, 2 down, so it's going to be 6 to the left. 1, 2, 3, 4, 5, 6, and then 6 down. 1, 2, 3, 4, 5, 6. Connect that dot. And then finally, I'm just going to connect these guys right here. Now, this was 2 units here, so that means this should be, if I've done this right, 6 units. 1, 2, 3, 4, 5, and it is. And so that is the dilation of the smaller object by a linear scale factor of 3. Okay, now we want to take a look at this question here and identify the scale factor used to transform image A into its dilated image down here. Well, all I got to do is compare the lengths here. So let's just take a look at this length straight down here. So it's 1, 2, 3, 4, 5, 6 units down. And this one here looks like it's 1, 2, 3 units down. Okay? Actually, let's take a look at the whole height of the object here, because I'm looking at this here, and I'm starting to think that I used a program here that drew lines in there and made them thick. So that doesn't look quite right here. Let's measure the whole height here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. Oh, yeah. Okay, so clearly there's an inconsistency here. I tell you what, just for convenience sake for right now, because it looks to me like there's something a little bit wrong here with the height here. I think there's a line that's too thick there. Let's just compare the widths, because that's going to work out a little bit cleaner for us right now. The width here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this one here is 1, 2, 3, 4. So we always start with the new over the old to get our scale factor. So this is going to be 4 over 12, or a scale factor of 1/3. Okay, which 1, 2, 3, 4, 5, 6 means this should have been 2 here. But yeah, I can see right there. There was a little bit of a gap in there. So my drawing didn't work out here. I can see that I was trying to get there with this inside bit here, but it didn't work out. So the scale factor here was supposed to be 1/3. I apologize for that. Okay, so in this problem here it says a scaly triangle has side lengths of 4.5, 7.3, 6.6 centimeters here. What will the lengths of the sides of the triangle be if it undergoes a dilation by each of the following scale factors? So let's say it goes by a scale factor of 8. So what we mean by this is that this is, remember, the fraction is going to be new to old. So really what I'm doing is I'm multiplying each one here by 8. So now I just got to take my 3 side lengths here and multiply by 8. So 4.5 times 8, okay, is going to be 36. So your 4.5 centimeters becomes 36 centimeters. Our 7.3 centimeters is going to become 58.4 centimeters. And that 6.6, okay, 6.6 centimeters is going to become 52.8 centimeters. Now compare that to this one. Okay, 0.2, if I was to write that as a fraction, is 1/5, and you can use your calculator to get that. And so this is your new, and this is your old. So the old is clearly bigger than the new, and so what I'm going to do is I'm going to multiply each of them. It's still multiplication. I'm either going to multiply by 0.2 or I'm going to multiply by 1/5. Now, multiplying by 1/5, by the way, is the same as dividing by 5. So you can think of it one way or the other here. But I'm going to take that 4.5 centimeters, multiply that by 0.2. So 4.5 multiplied by 0.2. This is going to be 0.9 centimeters. 7.3 centimeters multiplied by 0.2 is going to be 1.46 centimeters. Whoops. And then 6.6 centimeters multiplied by 0.2 will equal 1.32 centimeters. Okay? And that's what we got to do. That's all we're being asked to do in this particular problem, is just multiply those lengths by the scale factor. That's it. Okay. So in this in this question, Tony took a photo. That's 9 inches by 15 inches. Okay, so he has 2 picture frames, one that measures 5 inches by 8 inches, and the other one that's 8 inches by 10 inches. Can he dilate the photo to fit the frames? Okay, so what we're trying to do here is we're trying to figure out if by just changing the size without stretching it, and that's the problem here, right? Because maybe the dimensions of the photo don't match the dimensions of the frame, and so if you try to force it to fit, you're going to end up stretching it in one direction or the other, which can distort the image here. So what we've got here is we've got a picture that's 9 by 15. And then I've got a frame here, okay, that is 5 by 8. And then I've got a frame here that's 8 by 10. Now there are a couple of different ways that we can figure this out, okay? But one of the things that we can do here is surely to go from here to here, okay, to go from the 9 to the 5, okay, I'm going to create a scale factor here, and actually I'll grab another marker here. I'm going to create a scale factor here to go from, let's make this A, and this is going to be our B and our C, and I just want to know if I can take A and go to B. So from A to B, my scale factor looks like it should be the new width is 5, the old one is 9. So my scale factor should be 5/9. But let's see if that works. Okay, let's see if that works. Because if I take now 15 and multiply it by 5/9, I should be getting 8. 15 times 5/9. And I'm getting 8.3. Okay, well that's not terrible. We'll see if this one's better here. So now let's see what it looks like to go from A to C. So the new one is 8, the old one is 9 here. So my scale factor would be 8/9. Now let's take 15 and multiply that by 8/9. I should be getting 10 if that's a good fit. So 15 times 8 divided by 9, and I'm getting 13.3. Okay, wow. Okay, it's not this one. It's totally this one. So the relationship here is it can go relatively nicely into B. There's going to be a little bit of a gap there, okay, but that's not nearly so bad as it would be if you went into that C frame. Now let's take a look at this one. He would like to make a poster dilating the photo by a scale factor of 3. What will the dimensions of the poster be in feet and inches? Okay, well, we're still starting with this one right here, but our scale factor is now 3/1, or 3, which means we're going to multiply the two dimensions there by 3. So 9 times 3 is going to be 27 inches. 15 times 3 is going to be 45 inches. Now, the question wants those numbers in feet and inches. Okay. So 27 inches here. Let's think about that. 27 inches. Well, a foot is 12 inches. So if I take 27 and divide it by 12, okay, I'm going to get 2. So there's going to be 2 feet in there, and then I have 0.25 left over, or a quarter, which is going to amount to, just think about that, 27 divided by 12 is going to be 2 with a remainder of 3. So 2 feet 3 inches. 45 inches on the other hand, if you take and divide that by 12, we're going to get 3 feet. But what's the remainder there? Okay, the remainder there is going to be, what have I got here, 12? I think it's going to be 9 inches, yeah. Yeah, it actually makes sense here because 3 feet is going to be 36 inches. There's going to be 9 inches left over to get us to 45. So yeah, 2 feet 3 inches, 3 feet 9 inches. And this is what they're asking you to do.